Hi there, so I'm Alister Malcolm. I'm a glass artist based at Stourbridge Glass Museum. For those of you who don't know me, I'm a trustee for the British Glass Foundation and honorary freeman for the Worshipful Company of Glass Sellers. Now, what I'd like to talk to you about is the changes that have been going through the studio over the last, it's only the last 4 months physically, but essentially there's been 18 months worth of planning that have gone into these changes. Some of them may be for the best, others not so, but I was forced to consider how I was going to take my studio forward. And I think it was having done 18 months worth of this research, I've got all this stuff in my head and figured that now's a good time to share it all, because I think if the glass community is going to progress, then this is the time that we need to share all this wealth of information so that we can really try and find a way forward. I particularly don't enjoy the news, and there's quite a lot of it that's out and about at the moment, whereby we're hearing of facilities closing down. So to provide a little bit of context, I want to take you to give you a little bit of a tour of my studio as it stood in March 2023. So we've got a hot shop set up, completely running on gas, 50 kilo pot furnace, which was more than adequate for the production style that I have, a gas reheating chamber, gas pipe warmer. As you see, the furnace there it's got a recuperated system and a gas annealing oven. Now, these were all installed by Pete Howard. Not only installed by Pete Howard, but serviced regularly, working as efficiently as they could do, and really kept in good working order. A facility that I was really proud of, and I should say that I really benefited from a very good relationship with Pete over a decade to help that keep running so well. So having said that, if it ain't broke, why mess with it? And I think what I need to do is take you back in time to April 2022. Nord Stream pipeline's been blown up. My gas bill has already gone from 12,000 a year to 36,000 pounds a year. We've made all sorts of modifications to the way we work. I've become really astute as to how to rein in some overheads. It axed certain ranges and just found what our new normal is. But at that point, I was told by our brokers, because I only had a 12-month contract, that despite paying 36,000 per year, that my gas bill was likely to do more than double that in April 2023. So I have this cliff edge that I know I'm heading towards. And actually, it's only just now that I've started to admit this to people, that really, I thought, well, April 2023, well, that's it. I'm just going to cease trading. That's it. I may as well go out in style. So you will have seen me doing all sorts of things that don't really come comfortable to me. You know, for instance, dressing up as a king on a catwalk in IFOG. Even agreeing to be a mentor on national TV. These are things that don't necessarily come naturally to me, but I agreed to do them because, in all honesty, I thought, well, if this is my last year as a glass artist, I may as well have fun doing it and go out in style. It was fun. I have to admit, it was fun. But you can see where my state of mind was. That being said, one of the things that I'm really fortunate about is that I'm surrounded by a community of people that are willing the studio to survive and thrive. Pardon me, I still get choked by this. And it's for that reason alone that I think we decided to carry on and explore a level of, take a route of investigation. Now, if you consider this cliff edge is coming my way, All the cards are off the table. I just want to sort of put myself out there with a clean slate, and just sort of go, where am I now? You know, really, should I really continue as a hot glass artist? Because are these rising energy costs just as a sign that I just consume too much energy doing what I do? Financially, will it ever work again? You know, putting all that aside, for my gas bill to double, I'd done the calculations. I needed to manufacture and sell 10 pounds of glassware per minute in order to survive. Could I do that and do the right thing by the environment? You know, there's pressure to preserve the activity of glassmaking on site at Stourbridge Glass Museum. But beyond all of that, I'm very fearful of change, and definitely as a glass artist, everybody in the room will appreciate that, fearful of paying for that change. You know, we haven't got piles of stocks of money to pay for it, for huge amounts of investment. And also, I've been burning gas for 20 years. It's what I know and trust. One of the other things that I was excited about, though, was this notion that hydrogen sounded like a very exciting thing to be considering. So where did I start looking? On the internet, my research took me all over the world. I found electric furnaces that were that looked smart enough, but I wasn't sure that I really trusted them. I found solar companies that could provide me with proposals, annealing ovens, and it was these two companies that I homed in on, Interpower and Kiln Care, mainly because they were UK based, which is very important to me, and they were, I felt, really, if I was going to buy any equipment, what I needed to do was consider that it wasn't just a capital investment. This is somebody that potentially is going to be supporting me over the next 10 years, helping to service equipment, helping me on the end of the phone. And I guess similar to that relationship that I've had with Pete, support me with any daft questions that are most likely to come their way. So if I move on to the next slide, this is where I'm not sure whether the presentation is going to work for me. So I have a video on the left showing the installation. I'm going to have to do them one at a time. Showing the installation of the furnace. And the video on the right, which I can show in a second, shows shows us making our first piece. Now, at this point, I suppose I could say I did really plunder Interpower for a lot of information and reassurance about how this furnace was going to function. It's basically it's a like for like comparison. It's a 50 kilo pot furnace. It's a 32 amp supply with a 20 kilowatts installed power, with a maximum operating temperature of 1,350 degrees. It runs with pneumatic doors. Now, Interpower's background is that they're used to working within the nuclear industry, but they don't necessarily know a lot about glass making. And so we've had, I guess, 4 or 5 months of dialogue where they unveiled a nice furnace design. And I went back to them and said, you know, I like it, but I'd prefer it if there was a few modifications. They were good enough to make those modifications and work with me with that. So meanwhile, we were recycling Dartington Crystals waste, and I'd discovered this alternative called Boma. Now the Boma is a really beautiful glass, works quite differently, different melting temperatures, and actually I'd say it's a little bit like ripping off an elastoplast. I just decided we would do everything all at once, just because of that cliff edge thing. So we changed furnace, changed melting programs, changed glass, changed color supplier, and just decided to deal with the chaos all in one hit. It's not necessarily ideal, but it would have maybe been better to keep at least one consistent. But I wasn't sure that we would be sensible melting lead crystal in this furnace for once. So the Boma is a lead-free option. Now I should say one of the things about the Boma is that people have given me all sorts of melt cycles. You know, Simon Moore told me that we should be melting for taking up to a certain temperature, soaking for a certain length of time, and then I should bring it back down. Other guys just said, well, at the end of the day, I throw the glass in and walk away. And what we've developed is a series of different melt cycles so that I can really think about how much energy I need to throw at the situation. You know, if we have a really big fill, then I'll run a melt cycle. If we've been doing some rather detailed work and I haven't really used a lot of glass now, we will top up the furnace just by adding a little bit. I won't run a melt cycle and I'll save myself a lot of energy in doing so. And so how do I know that I'm saving energy? Well, it's because the electric furnace comes with a system that tracks the energy consumption. And so I've been able to refer to that as I've been going through my working practice. And that has really been a huge learning curve, because we would, with gas, I would just take general guesses thinking, well, if we do this, it must save us a bit of energy. Here, I can employ the same sort of rationale, but I can refer to some charts. And I wanted to take you through some of the charts. So here is what I would call the lifeline of my studio with an electric furnace. You know, we've got date versus temperature here. And a record of the furnace warming up initially where the number 1 is. Number 2, there's a fluctuation in temperature caused by us filling on with cold Boma. So as I've thrown glass in, the temperature's dropped and it's risen again. Slightly after number 2, I've realized that I haven't got my working temperature quite right, so I've adjusted it. 3 shows you my working day. The interesting thing about the working day, I'm going to go off piste a little bit here. If you zoom in on it, Terry can kind of clock how long I've had a tea break for. You know, how long did that cup of tea take you there? This is why we're not getting much work out of the studio. But you can analyze the timeline to the nth degree should you wish. So number 4 shows us filling on and a melt cycle, and number 5 shows you a working day without any filling on going on. And I think I've been able to assess whether I should fill on every day. Believe it or not, with a 50 kilo pot furnace, a lot of artists might go, oh, it's not enough glass for us, we can't survive with that much, we need a bigger furnace. For me, I think bigger furnace, bigger energy bills. I'd rather keep it small. And if it has to be small from now on in order to survive, then that's a sacrifice I'm willing to take. So this graph has sort of enabled me to really progress and think about my energy costs. So the next diagram that we're on to now shows the energy consumption day by day, and we've got some peaks and troughs, and this is where you'll kind of get, I'm bringing you up to speed in how I know. There's a really low one around about the 27th of the 8th. I probably had the day off there, and that's the furnace ticking over at just ticking over at 1160 degrees centigrade. The peaks obviously show where I've consumed a lot of glass and had to throw a lot of glass in. Thus, the energy has been at higher. Sometimes we've just done something that's been daft, and I didn't know it was daft. But I've looked at the graphs and just thought, oh my God, we consumed 190 kilowatt hours that day. What were we doing? And I've been able to basically say to the guys, listen, we need to cut that activity out and work again. So we've rather than approaching glass making in terms of how quickly can we do it, I've started to look at how can I reduce the peaks in this graph so that we consume less energy. Maybe consuming less energy is better for the planet than necessarily the way we were working before. Now you can see from the graph, I can also look at the 10-minute intervals if I wish to. On the right, the chart shows one of the interesting exercises we learned in that I've always been putting in cold cullet. So you're preheating the furnace, charging on with cold material, and the temperature drops. We had a bit of a brainwave that if we loaded that cullet into the bottom of the leer and used that using metal shovels, transferring it, the warm material wouldn't actually sap too much energy, or it wouldn't sap as much energy from the furnace. It was a shelf in the leer that wasn't being used because it had a little bit of a hot spot in it anyway. But you can see from that chart, it's reduced the amount of fluctuation in temperature, condensed our filling cycle, and reduced our energy consumption. So it's been, you can start to get a sense of how I've started to work with this. Now, in terms of running costs, I'm not going to talk too much about running costs because I think everybody's on different tariffs, and I think it seems a bit pointless. But if I take 25 pence per kilowatt hour as an example, the average sort of day for the furnace is around about the £40 mark. So when you consider that I was about to start paying well over triple that in gas, it's a saving for sure, but really from my point of view, it's the lessons that I've learned that have been really valuable. So here again, the example that the exterior door that you're looking at in the right hand side, that is an insulated door. And we always close the door to save energy. We always did with the gas furnace. Now this furnace, if I press play, it has what we call the night door. So within this corridor, this plug, if you like, is installed every night. Now the chart, I did say to the guys, really, will that make much of a difference? And they said, yes, it will, and we know it will. Just out of curiosity, I took a recording. So you can see where we're looking at 1.6 and 1.4 consumption, kilowatt hours wise. That's the furnace shut without that plug-in. With that night door in place, we're bringing it down to 1.1 in various instances. It's a tiny space that we're plugging, but it's, again, I think made a valuable piece of progress for us. Having learned that, Interpower also provided us with some day tiles, if you like, which we weren't really, we didn't find them as user-friendly as we like. So I knocked up a quick cardboard template, and we've now introduced what I call this mouse hole, which is my favorite, because this reduces the aperture. So when we open the door to gather, there's only a small gathering hole. And again, I've been able to look at charts and understand how this has managed to reduce the temperature loss when gathering, but also retain a little bit of energy. So just so you can see connection. Now we've got, now if you're making large pieces, it's fairly simple to remove that plug. And actually, if you are making large pieces, when you stop and think about that furnace door, it only really needs to be open for what, 60 seconds of your operation. And so rather than feeling the need to have a big furnace door open that opens all the time, we started to think about how do we just keep it shut. And that's been quite an exciting thing. Now, sadly, because I can't play the next tile, a few things are going to be revealed before I would necessarily like them to be. But what I want to do at this stage is show you a little bit of a comparison of the electric furnace with Boma and all the tricks that I've learned versus the gas furnace and me melting my lead crystal. So I'm using here data that I've taken from statistics online. I've been fortunate enough to get some feedback from the Paleo group. Now they did an energy review on the museum, and so I checked these figures with those. But I now understand that gas, for every kilowatt hour consumed, gas creates 0.18387 kilograms of CO2, and electric creates a different statistic. And this figure varies from country to country, depending on how that their national grid generates the energy. So I put a little link in underneath those statistics. So anybody wishing to check out what either any liquid or solid fuels, this website shows you what sort of carbon footprint you might expect to achieve. So the gas furnace, having done some maths, with the lead crystal that we were melting, we were looking at generating or consuming 11,000 kilowatt hours a month. In our new world now, just having thrown a caution to the wind and played, we've managed to bring that down with all those tricks that I was talking about to 5,100 kilowatts an hour. So we've managed to do some conversions, and this is where I guess I should look guilty at the fact that we generated previously 22.2 tons of CO2 per year with the gas furnace and the lead crystal, versus what we're doing now is about 11.6 tons of CO2 per year, and that is annually saving us about 10.6 tons of CO2. Now, whenever anybody talks, when geeks out like this, I look and think it sounds impressive, but I don't really understand what the hell 1 ton of CO2 means. You know, it just doesn't relate. And I think the classic line would be, if it's out of sight, it's out of mind. It's invisible. I don't really bloody understand what it means. But there's a website here that I've found which equates that to things that you can relate to in everyday life. So I've homed in on a car, an Audi A6. It's an imaginary one. I haven't got an Audi A6. Other cars are available, but for the sake of my maths, if you drove for 3,500 miles in an Audi A6, you would generate 1 ton of CO2. So this picture of me and the girls, I should warn them, if they pull funny faces, they should know I'm going to share the pictures. But it's hiding some statistics. If I just move that out of the way, it's a saving big enough to drive around the planet 1.5 times around the planet in my Audi A6, and I think that was a statistic that shocked me to the extent that I've spent a week checking with people my maths to understand if I've got it right. As I say, there's a lot of tricks that have come into the equation, but it's something that I kind of feel is a little win, considering the amount of stress that I've gone through over the last few months. So if we park the furnace to one side for the moment, and now look at the layers, I'm sure everybody's aware of kiln care. You know, they've been going for years. Much like Pete Howard, they've got amazing reputations for things that they do in their field. And I homed in on their electric layers. You can see it on the right there. If I play the video, there's the installation video, and the other video just shows me opening it and showing the first day's production. Now there are similar size volume internally, but the blue kiln you can see it's just got a lot more insulation. Now there's a different premise to the starting point. I think Pete Howard understood that with tight space, a glass artist may need one layer to anneal and cool down overnight. Now, the bricks in the gas layer, as I say, they're bricks. They aren't welded together with cement and joints, and so there are slight gaps between the bricks, and they don't insulate as brilliantly as modern day insulators might do. And that enables the kiln to cool down rapidly once you get from 200 degrees down to room temperature. The electric kiln is built from a fiber board with a micropore insulation board. There's no gaps, there's no flue. I should say that the gas furnace as well had the beautiful sort of system in it where it recuperated heat. So the flue fed the exhaust gases back into the burner, making it as energy efficient as possible. And there's quite a few gas layers in the area that don't have that recuperation system. So I think would consume a lot more energy compared to the one that we've got. So going back to our electric layer, we've got insulation that doesn't do the same job. It retains as much heat as possible, doesn't let it out. And so there are pros and cons to that. The pros are that, you know, it's saving the energy. The cons are that at the end of the day, well, this is a pro actually. At the end of the day, you can actually hold your hands on it and it doesn't feel very warm. The disadvantage is that I can't cool down thin work rapidly enough to fire that layer day after day after day. So really, I would need two of these in order to do the production of a glass studio, whereas the gas layer, we can operate with one. So having talked about the pros and the cons of the two, I've now been able to make comparisons with the way the gas layer consumes kilowatt hours versus the way that the electric one does. So if I play this, there's some magic buttons which some of you may be aware of on the kiln care kilns, where they'll show, got Jaffa barking in the background. We've got, it'll tell you for your last firing cycle how many kilowatt hours you've consumed. And so for a lot of you, if you're doing one-off firings, you'll then know what you want to charge. The gas layer, slightly different in that I've needed to run to the other side of the room, take a meter reading, fire my layer up, and take some statistics. So as you can see here, the electric layer consumed 53.3 kilowatt hours, the gas layer 250 kilowatt hours. Now, using those statistics again, overall, now I should say if I had two layers and could fire them both, it would save 8.4 tons per year. I've only got the one, but if you allow me a little bit of creative license, that's the equivalent to driving 1.2 times around the planet again, with my Audi A6. That's a sort of the emissions we're looking at saving. And again, we checked that. The only thing I think I need to take into consideration there is that I need to buy another. And so there is the carbon footprint of that initial outlay for the secondary kiln. But you can see, this is me spilling my thoughts out as to where I am with the layer. But you know, in terms of energy consumption, I think that these electric kilns seem to be amazing. So I've then turned my attention to the electric glory hole or reheating chamber. And it was showcased at the International Festival of Glass last year. I had a quick go on it because I actually just, as I said, at that point, I was just thinking, I'll give anything a go if I'm going to be facing horrific gas bills like the one that was being proposed. And the electric glory hole, it surprised me in that I didn't expect it to get hot. I didn't expect it to stay hot when I opened the door, and I didn't expect much from it. I had low expectations. I was only working with it for half an hour, but that half an hour was enough for me to agree to take this one that we have now in the studio for a test drive. So that's now in the studio, and I think that we're in a good position to work with it and gain an understanding of what that might be like for glass artists to work with. So my next slide, we'll talk a little bit about that, because for 30 years, if I look at the exterior of a glory hole, it's always been round, circular, with the door wide open. One of the hottest things in the studio, with the smallest amounts of, not necessarily used for insulation, but a fiber blanket that's reflecting the heat in it. And nothing has changed about the outside. The burners and the flame monitoring has become much more sophisticated, but when it comes to the actual outside, nothing much has changed. So this idea that this glory hole might be able to save energy by closing the door because it's electric seems like worthy of consideration. So the notion is that you would preheat this up to 800 degrees, and that would be its operating temperature. And then every day you would send it up to 1100, 1200, whatever you want to work it at. And then instead of switching it off at the end of the day, you would shut the door and maintain that temperature of 800 degrees. So the theory is that it's large. It's so large because it's insulated so well to try and keep that heat in it. And the right hand tile shows that it's been on extensive trials at Tame Valley. And so we've already got an understanding of what the energy consumption for the electric glory hole might be versus the gas glory hole. And I think it was because I saw these charts that I thought, well, again, I'm willing to give it a go. I'm still in that period where my gas bill is astronomical. So I've been able to, because I was never able to really get independent data of each gas appliance, because I always had the gas furnace running in the background. Now the gas furnace isn't running. We've been able to just fire the gas layer or just fire the gas glory hole and get accurate figures to understand what they all consume. And so the summary really is, if this goes well, which I'm pretty confident about, you may expect I might open the glory hole door a little bit more than Tame Valley did, which might result in a 10 or 15% fluctuation in these numbers. But overall, it looks like it could save enough carbon emissions to be the equivalent of driving that Audi A6 0.9 times around the world. So
I hope these cars aren't going to keep meeting and crashing.
Yeah. So if I play this video, you can see how the studio looks at the moment. There's the electric furnace with the gas glory hole in between the electric layer and the gas layer, and the electric glory hole standing to one side. So it is a large, you can see it is a large thing in the corner. I think that's a reassuring thing. The combined ambition in converting over to all of those, you can see the statistics there that it's over 3 laps of the planet's savings in carbon emissions. So I'm work in progress on this, but I think that we've done a lot to try and educate ourselves as to what might be the next steps in reducing our energy consumption. And I guess now it's time to start thinking about taking more ownership of the leftover energy that I'm consuming. So now this diagram is going to be a little bit, if I see now, I'm going to have to move things about. So the diagram on the left here shows the first application that I made to Dudley Council for solar panels. Now I have to say we're lucky but unlucky, because the cone over the road, as beautiful as it is a designated UNESCO World Heritage Site. I'm in a listed building in a conservation area. And so I have to admit, I was a little pessimistic about my ability to get listed building consent to fit any solar panels to the roof. So the initial application was timid, and I went with that. We were approved the small set before, if I can then move that one over. When the trustees saw the issues that I was facing, it was quite clear that they were going to face the same issues with big energy bills as well. So we increased the application to include a number which are here to generate energy to help run the museum as well. So if I click onto the next slide, that shows you the impact of what we're planning. The yellow stars or the sunshines show panels that are going to, they'll be generating energy which feed into the museum's supply. The dark orange stars are going to be fed into the hot glass studio with a view to kind of taking a little bit more ownership of what we do there. Now we've already had information back from numerous companies, and it's been a lot of work to pull it all together, you know, but numerous companies have provided various charts so that they can predict throughout the year what the daylight hours are. Then they can assess the angle of your roof, and they can assess the tilt that may be required of your solar panels and how that will affect the energy that can be generated from those panels that they're proposing to use. And so they can build up a picture quite clearly of what they may expect me to be able to harness. So here we've got various different diagrams that go into all that. But they all suggested that the payback would be 5 to 6 years. And you can see the bottom graph where you cover your bills, and the rest is just helping you pay for your energy. What I want to focus on though is one particular graph. So all of this information came in from solar panel companies prior to me installing the electric furnace. And so the black bars show what they may expect to generate in energy spread across the year. And naturally in the winter, there's a great drop compared to the summer, and it's down to the daylight hours. The grey area, the shaded area in the background, was their prediction of my energy consumption. So since then, I've been able to overlay this red line, which shows if our furnace is ticking over at 1160 degrees centigrade, where I think we'll be consuming energy. And you can see from that these solar panels should cover 50% of the consumption that we need, or the energy that we need to power the furnace. And I've fed that back into our calculator for our carbon footprint to get the figure that you see on the left, which is 4.35. So again, I've come across all sorts of debates as to whether a lot of artists think, or glass artists, hot glass artists in particular, don't think that it's worth consideration installing solar panels. Personally, I just want to throw every trick at this situation that I possibly can, in the hope that we can keep glassmaking alive here at the museum for decades to come. And really, that's a summary of where I've got to so far. So for me, the next steps really will be firing that electric glory hole and hopefully having fun, providing some feedback on where I think improvements might be needed to be made. As I say, they aren't glass making specialists. They may need adapters for the doors is where I think that we may need to provide feedback. We'll be assessing the energy consumption. We've already commissioned structural engineers reports for the building. Because it's a listed building, we need to reassure the planners that some of the flat roofs can take some of the weight that's going to be needed as ballast to hold down some of the panels on the flat roofs. I think we're going to be looking further at this notion of installing an additional electrical ear and gaining an understanding if that's the sensible way forward for us. And we're already way into a grant application. Wouldn't surprise any of you to know I've run out of money now. So I'm applying for funds to hopefully fit out the solar panels. And I think I would like to think that it would be appropriate for a funder to fit those panels. You know, everything else, when my business is done, we could move everything out and vacate the building. The solar panels will be there for the museum to benefit for decades to come. And so I hope that a funder will see that should my business fail at any point, it will benefit the glass community one way, shape or another. So one of the things I've been passionate about is that 18 months ago, there was nobody around to lean on to give me this wealth of information. There were a lot of sympathetic voices when I whispered what my cliff edge was that I was facing. And so by sharing all of this information, I hope that it gives a few glass artists a real sense of maybe what to do, what not to do. You can look back through it. Hopefully we'll have a sequel to this talk so I can update a little bit more on where we're going. And I hope, I guess, if anybody has any other ideas of what other tricks that we can throw at this situation, then I'm all ears. But that really, that's it from me. And I hope you've enjoyed listening.
Fantastic.
Brilliant. Thank you.
Amazing. Golly, that was fantastic. So can I ask the first question?
Yeah.
This is really pretty revolutionary, everything that you've done. How much support and help did you get as a business trying to, going out to industry and to grant people? Actually, how much help and financial help did you get, or did you tend to get met by thanks but no thanks from most of them?
So I was fortunate enough to be considering my game plan 2 years down the line. So because I was aware, I had a Gantt chart which told me I can make certain approaches for funding. Sadly, for the West Midlands, there's not a lot of funding for capital funding for carbon issues at all. I spent 6 months applying to, I don't want to name and shame them, but I spent 6 months applying for funding to be given knockback and feedback to the point where the last bit of feedback was, oh, if you apply to another round of funding, we might have a pot of money for you there. But their decision date was April. And that was already too late for me. It was real. I'd already worked out the order of making people redundant. So I needed to have placed my orders for certain things and have them delivered at a certain time in order to retain jobs, keep demonstrations going. So it's been a real game of poker where social media celebrates a lot of successes behind the scenes. I should say that there's been quite a lot of alcohol consumed, and I do need to take into consideration the carbon footprint of what I've been consuming there. So that might knock off a lap off the planet. But no, so far we haven't had any funding, which has been frustrating. I thought what we were doing was new and exciting. I think on reflection, new and exciting to some funders is a little risky, and they may not want egg on their face if you spend a lot of money. I mean, you see it all the time. They spend a lot of money on a project and then it falls flat on its face. So this has been a financial gamble on my part. You know, we've just taken a lot of sacrifices, which I think artists do all the time. You know, if you love what you do, you take these moments on the chin because you want to carry on doing what you do. And so there have been a lot of sacrifices over the last 2 years in order for us to get where we are. Having said that, because of throwing caution to the wind and just saying yes to everything that came our way, that helped financially to bring in enough money to do an interest to convince people that we could do certain things. So no funding so far, a lot of moral support and well wishes, but nobody. Early days, I had a generous offer because my mentality was that I wanted to find a solution that might fit everybody. And so I appreciate I'm sitting here and, you know, due to social media success or TV success, I've had some money to buy certain things or put money towards certain things. Not everybody's got that pot of money. So I was looking at a solution where maybe we could retrofit. Pete Howard's going to be shaking. He said it when he hears this. But we could look at retrofitting a castable lid onto his gas furnace and lower elements, so that glass artists could convert their old furnaces into electric. You know, as a get out of the shit plan. And I had somebody offer some funding to look at that research. But the more that I learned about, it's not that simple. You can't just do that. Pete has engineered his furnaces to beautifully allow the gas combustion to flow around this void. Equally, the engineers working with electric furnaces have worked out what the relationships of the elements need to be inside the furnace in comparison to the crucible and how all that works dynamically. So whilst it was a kind offer, I didn't go down that route, A, because I didn't think there was a good solution, and B, I was a little nervous that I would end up spending a lot of money with not necessarily a guaranteed result.
Yeah.
Yeah.
You've been very brave, Alister, I must say. It's amazing that you've had the courage to step up and do it. I think there's not many artists that would do that. So, you know, you should be proud of yourself.
Yeah,
and it's so frustrating that you haven't had funding for something like this. It's so important. And you know,
I mean, my hope really now is that, and this is why I'm keen for this to be uploaded and be shared. You know, the fact is that people will assess those statistics that I've shared, and they may come back with things that need correcting. But the fact is, there's a line in the sand. I've independently said what I've done, and I've independently worked out a way of financing it. It may well be now that another artist can use the information that I've put forward and say, this guy's done this independently. I'm going to use this as information, maybe to secure funding for themselves. So, you know, that was the other reason for wishing to share it, really.
That's great.
I think Roberta's got a question for you.
Yeah, well done, Alister. It's absolutely brilliant to hear your presentation. We had a question, really. Are you looking at battery storage when the sun's out and you're generating loads and loads and loads of energy, like what we've found with ours.
Yeah.
You have to power the layers overnight when the sun's not shining. So are you looking at some kind of battery storage or whatever to actually extend the life of your microgeneration?
I think at this point we're not, and the main reason being all the guys that have been laying out the specs have said really what we need to consider this to be a phased approach with everything. So the batteries are very expensive, for one. Two, I think we need to install them, put them in, and just see what the excess of energy is that we're exporting back to the national grid, and then work out that. So in my next steps, that's one of those things that's lodged in there, is that we need to look carefully at that. I think that I honestly think that the museum's roof has got more solar panels than it needs. We've got listed building consent to fit more than we need. I think we could probably reduce that by 30% and put batteries in instead, which will then get the museum to a very sweet spot. Sadly for the hot glass studio, I don't think that the solar panels will generate enough to cover furnaces, layers, if you go all completely electric. And I think this is where I'm envious of countries like New Zealand. When I say they generate 85% of their electric through renewables, they can make certain claims when they're running that mean they are less damaging to the environment. I can't see a point where we will be able to generate everything that we need to run everything in the background, which is where I think we're going to be looking at voltage optimizers. And I say that because I don't think we will get permission for a wind turbine and things set on the canal to harness the energy coming from 12 locks. I think it will need all manner of sort of tricks thrown at it, but I don't think the solar panels will do enough for us.
No.
Don't forget, you can also buy green energy, green electricity.
Yeah, that was one of the things that we thought, is that you can, but it's more expensive.
Yes.
Mm-hmm.
And the way I'd looked at it was that actually, if the solar panels help me, in my mind, subsidize the fact that I'm buying green energy,
Exactly.
that will be my serious consideration, really.
Because batteries themselves are expensive and not particularly green.
Yeah.
The actual battery itself, whereas if you're putting energy out when it's sunny, and then buying the green stuff when it's dark, it bounces out the footprint.
Yeah, but really well done. Really, really impressively
Absolutely.
well done.
Thank you.
And can I just say, first of all, Alister, that was brilliant. That was fabulous. For somebody that's not involved in making glass, that was so easy to understand and very persuasive if you do try to take it to suppliers or to market the system in any way. I think you're on a winner there. But as far as the historical perspective is concerned, although, you really have gone all or nothing, and in a very considered way, you've crossed the Rubicon, but you're not the first. I mean, this has happened, from timber to coal to natural gas to town gas, and so it goes on. And it's always been the limiting factor is the fuel. And always will be, but I think it's absolutely remarkable to in this day and age to commit to that, and not as a great manufacturer, but as a single business. I appreciate that tremendously, and I think everybody else should as well, because that really is all or nothing. You put your family on the line. It's not just your business, it is your life and other people's lives. So yeah, that's really appreciated. The one question that I had got was preheating the nuggets in the layer. Does that impede the efficiency of the layer, or do they act as a sort of heat sink to improve its efficiency?
I guess they are going to consume a bit of energy anyway. I think we were looking at it in terms of the fact that we, particularly in the gas layer, because you have a flame radiating, or a flame that hits a plate that radiates the heat, we have a hot spot. And that hot spot, it means that we can't put certain products in that space. And so it was actually, the concept was born of the idea where we were trying to work out, well, we may as well use it for something. So in regards to the gas layer, I think we are consuming a bit of energy to do it. I know, for instance, that when it comes to the electric layer, the more metal shelves that you load in there, the longer the warm-up time. So if we leave all of the racking out, the layer will warm up in 35 minutes. If we load every single shelf in there, you can nearly double that. So it does make a significant difference. I know, and every time you're opening and closing the layer doors, it's really tricky actually to make comparisons with certain equipment, because you won't necessarily have done exactly the same day's production when you try and draw those comparisons. So it's been a
but well done. Brilliant.
I think the only other thing that we thought in terms of energy consumption is that we shared a YouTube video, we shared a video on Instagram whereby rather than using the electric or the gas glory hole, we operated using the electric furnace, and we'd heard about somebody in Sweden operating in this way, using the furnace as a glory hole as well.
That's how it used to occur, isn't it, in the times of, when the cone was flourishing?
And I think if things escalate and we can't do any more, it might be that is the next stage that glassmaking has to go back to one level of energy, and it's to be reduced in that way.
It's all experimental, but well done. There's no actual answers until you try it and suck it and see. So well done.
I ask you, Alister, this is fascinating. I'm not a hot glass person, but I have just found this really, really fascinating. But have you found, because you're spending so much time being concerned about saving energy, have you actually found it's been any kind of sort of impediment to your creativity, or are you having to create in a different kind of way?
I think it forced us to be more creative. So when you change your furnace, your layer, your glass, your colour supplier, and you have a portfolio. Somebody's laughing, going, "What the nutter?" But when you do all of that in one hit, and then you still have clients going, "Oh, that mermaid bowl you do with the sterling silver. Can I have 3 of those in these colours?" It's not going to happen without a few problems, and it was quite clear that my glass portfolio was going to change aesthetically, and that happened with immediate effect. I found that we couldn't use sterling silver leaf in the same way that I had before. Higher temperatures meant I was burning them off. So in effect, within a 6-week period, we launched, we went rapidly into prototyping, refining, and launching the dragonfly pieces, which were all about a symbol of change, these glass batteries, which were a celebration of electric energy, and the Tondo range, which was all about colour. And I found that it was again because of this cliff edge. It was either a do or die moment of you just need to crack on and create some new work quickly, rather than apologize to people that you can't quite make the old work like you used to. The attention's been very much on all of the new work. People are now still coming and asking for some of the pieces that they know and love, and I've managed to refine my making to the extent I can't tell the difference now between a piece that was made in lead crystal and that's now in Boma with certain colours. But that's taken 3 months to get to that point. So it's been a hell of a learning curve, actually. Quite different. Lead crystal's quite soft. It tends to dull down colours very slightly. The Boma, on the other hand, seems to want to celebrate what colour's about, make it shout loud and proud, and that has made things change. It's changed the aesthetics somewhat, but I just decided that it would be a nice way. I would be able to look back on this moment and just say, you know, that this new body of work came from this period, and that symbolised this new start.
Great, thank you.
I've got a question, Alister.
Hiya, Chris.
Are you doing all right?
I didn't mention, so one of Chris's comments a few months ago, he said, God, you're brave, but you know it could still all go wrong.
Well, hopefully it won't, but yeah, you know, hats off to you. You know, it's like I say, it's an awesome task you took on board. Like the other lady said, it's not just you that's involved, it's your family. It's the people that you support as glass makers and that assist you. You know, the undertaking is just phenomenal, especially what's happening. You know, when you've got big establishments like Northlands closing the doors on glass because they can't afford to do it because of the resources. As a single person, if they can't get funding, how you've done it is it's just awesome. It really is. My only downside is that obviously institutions like Northlands and the universities are all closing the doors. So this nice, I'm not going to even call it a project because it's like a life-saving scheme that you've put together, is that these places aren't going to be, hopefully they will, but to me it's as if they're not going to be interested because they're already suffering. And on the other side is that we've got no new blood coming in to actually use these facilities. So even if we had the whole of Wolverhampton University with solar panels on the roofs and we had all these layers, we've got nobody to use it. You know, look at the screens. The average age of the person viewing is 50, you know. But
You've got to get out there and shout, Chris.
Yeah.
pardon?
You've got to get out there and shout.
Yeah,
But-
and
but-
shout.
but
Well, I
yeah.
do. I'm shouting a lot. I do shout a lot, and I do protest, and I do say, you know, what's happening? What are people doing to get new blood into the glass to keep it alive?
But I think this is what's really important is what's going to happen. As you
Exactly.
say, these big facilities are going, but
Yeah.
studios like Alister, you know, the small studios hopefully will come into their own, and you will get people wanting to hire your space and work there, you know, which is maybe another possibility.
Yeah, and you may well get the people, you know, accepting the fact that actually going to university possibly isn't the only way to actually learn about glass. It could be, you know, mentoring, it could be apprenticeships, it could be adult education courses, workshops, masterclass. I think that we may be seeing, you know, a sort of an expansion of potential ways that people can get into glass, and I mean certainly that's something that we're looking at the moment, isn't it, Pam? You know, is how you get to people and say, you know, these are alternatives.
But there are institutions as well that are moving electric, and then you've got people like Laura Quinn that are utterly and completely inspirational in terms of getting younger people involved. We've experienced when we've been doing installations that Blown Away has brought a plethora of young people really, really interested in the craft. heritage crafts. So I think that given half an opportunity, there is an inflow. But like Chris is saying, they just have to be pointed in the direction where the facilities lie, which can be difficult, but it's not impossible.
So we know of I think is it Plymouth University that have installed an electric furnace. I know Sunderland are considering it right now. They have a bit of a huge problem with concrete issues at the moment, but I think that was one of the reasons why I wish to share this information swiftly, because I think if the younger generation do not think that there's a future, why would you train in it? You know, my daughter started working with us in the studio during the pandemic just for a laugh. She now has the skills of a degree student at the age of 16, and had a careers last year. Last year she had a meeting with a careers advisor, and this I guess this was one of the other driving forces, because unbeknown to me, she'd gone to the careers advisor and said, "Oh, what would you like to be?" Usually, because she's a frustrated teen, she would just say, "I want to join the circus." Something idiotic, because she's so frustrated that at the age of 14, 15, that they want her to define her career path. She just doesn't want to tolerate the conversation. And for the first time, she actually said to the careers advisor, "Well, I'd like to go into glass, but I've listened to what my dad says, and I don't think there'll be anything left of it It's the glass industry by the time I finish my A levels." And you forget what the children of a self-employed person absorb, you know, around the home life. And so I said, "What did your careers advisor say then?" And she said, "Oh, she said that I should come home and talk to you. And how am I going to get a career in glass, Dad?" Bearing in mind, her real agenda is she wants to earn enough money to move out of the house so she can party till 3 o'clock on a Sunday morning without a dad saying, "Where are you? It's time for your curfew." So
She's got her head screwed on right, I can tell you.
Sorted.
Yeah, absolutely. That's lovely.
I think it's worth noting too. I mean, Alister, you're like a real sort of trendsetter or whatever, you know, icebreaker or whatever in the UK. But talking to my friends working in Copenhagen, all the shops in Copenhagen are fully electric and have been for some time.
Yeah.
And if you think about it, the cruise ship that Corning put together, that's been electric for years. And what I found really frustrating when I was doing research is they have all the patents, but they're not actually encouraging manufacturers to make these things and make them available. And I think that that might be quite controversial, but what's interesting to me now is that more and more people like you coming out and talking about this and making this present, and Chris actually saying stuff where he's got a voice as well, and it is going to actually force some of the people who actually hold the patents and hold the other information to actually share more openly. And the fact that, I mean, is it Eric Meeker? I mean, they run a hot glass shop downtown Copenhagen. Everything's electric, has been for ages. And I think that needs to be, maybe they need to be more open about talking about it and what they're finding and how they're doing stuff. I know Bauhaus and Brown are experimenting with a hexador on their electric glory hole so they can make their bigger work. And so there's a lot going on, but you're absolutely right to actually stand up and talk and be so open about how scary all this has been, because the more we talk about it, the more we'll all get connected like this fungus. We'll all be like mycorrhizal fungi. We'll all start talking and sharing information, and then it will exponentially improve the kind of quality of what everybody's doing. So really hats off to you.
Yeah, brilliant.
Absolutely. Great.
So Alister, we've always noted you for your colourful, flamboyant T-shirts and shirts that you wear because it's so hot in the hot shop. So now is it going to be the mildly warm shop, and we're going to see jumpers and sweatshirts? What's the temperature like?
It's Bearing in mind this has all happened in the summer, it's been warm anyway, so I think we're yet to see the experience of that. But we do notice on a day that we don't fire the gas layer up, as I said, because of all those the cracks in the bricks and the way that that's built. That corner of the room is quite hot. And when we fire up the electric layer in comparison, it isn't quite as warm in the studio over there. But you know, we're yet to see what the effect of the electric glory hole will be in the space. If I'm honest, we've had a few teething problems with it because on warm up, I think they're not designed to be traveling around the country. And so it's gone on extensive trials at Tame Valley, come back up to the Midlands. I think it'd been back down to Tame Valley, come back here, come back to the West Midlands and come to us. So it's done a few miles on its trial before coming to us. And there's been a few connections that haven't been quite right as a result, which have just caused delays. But I think we're in a way that has so infuriated, not infuriated, but frustrated Interpower, because they wanted me to be plugging it in and rocking with it. Now we did that with the furnace, and I was saying to Paul from Interpower the other day, I don't quite feel that I necessarily understand the nitty gritty of the furnace, because not a lot has gone wrong with it, and we all I seem to be a master of learning through mistakes. So I haven't really had to learn a lot about that, but there have been quite a few issues with the electric oil. So it's been useful to see how they react to certain situations and what's gone wrong. So although that's not working, I seem to know quite a lot about what to look for when things aren't right with it. It's one of those things.
But you must be quite interesting as well, because you're working with two manufacturers who must be learning a lot to actually refine and hone their equipment in line with, you know, with your requirements, really. So it must have been a fantastic learning curve actually for all of you in many ways.
Yeah, I think Interpower are learning all the time, and I think they've one of the amazing things there was their ability to take on criticism, constructive criticism, and sit down with a CAD engineer who then clicked a few buttons, changed, modified certain things. And I can remember thinking, I need this bloody furnace, and you're still faffing around with drawings, and we've got, I don't know, 3 or 4 weeks to go. And Paul just said to me, don't worry. The minute these drawings are finalised and you're okay with them, we'll click a button. Files will be sent to various companies, and this is what I love about it. You know, the certain panels were laser cut and powder coated within Dudley. The files were emailed off, and as if by magic, 7 days later, like a Meccano kit appeared on the floor when they then started to construct it. So it's a completely different way of working than I was used to as well.
Is your furnace their first furnace that they've produced then?
They've produced one for Plymouth University, which is a 150 kilo pot furnace. They've produced 2 for Dartington, which are, I think, twice the size of that. Dartington are currently committed to going electric in a big way, I believe. So when we initially sat down, they wanted to, the easy route for Interpower would have been for me to order a 150 kilo pot furnace because all the drawings existed. But one of the things there's two different ways of working. You can have a large furnace and choose not to fill it on very often, but you've then got to commit to working the crucible all the way out so that you don't leave any stale glass before you fill on again. Or you can just keep topping it up, but topping it up will create cord. And one of the things that I've learned is that if you go for the first option, which is to work the furnace out, the emptier the crucible becomes, the more energy that furnace requires to keep it hot. So actually, the 150 kilo pot furnace, for me and the amount of glass that I produce, it would mean I would have stale glass and a higher energy bill than I really need. And I used to work from a 150 kilo pot furnace over 10 years ago at Himley Hall. And really, we would only need to fill on every 5 days, 4 days sometimes. And I think that's what some people opt for. But I think looking at this next phase of my life, I just wanted to know that I could keep a small facility running, you know, and commit to that, and ensure that we might be able to then generate some energy from on up high to keep it going.
Fantastic. Wow.
Well, I think it's like you said, it'd be great to have you back in a year's time and hear, hear how it's all gone.
Yeah.
Yeah. I won't run an update on Zoom.
And if you do, I'll make sure that I send out the right link.
Yeah, thank
Actually,
you.
yeah, we've been a bit fated, haven't we, tonight? But we've done it.
We have. We have. Yeah, it has been.
I'm just going to stop the recording, but we carry on.